Alright, on to number 5 then. A cylinder is cut from a sphere with a radius of 8 centimeters. So here we can see the radius of the sphere. Oops. The height is 2h, so you can see one of the h's here and the other h here. Fine. Now we need to find AE, the radius of the cylinder. So we're looking for this length right here. In terms of h, so it's not asking us for us to come up with an actual numerical value, just some expression. So how can we relate this side that we're looking for, AE, to anything else? Well, we've got a right triangle here, don't we? So let's use Pythagoras. And so AE squared is going to equal, AE squared plus h squared, those are the two legs, will equal 8 squared. So now we're supposed to find AE, so let's get AE alone. So AE squared is equal to 64 minus h squared, and that must mean that AE is equal to the square root of 64 minus h squared. Part B, show that the volume may be written as volume equals, the volume of the cylinder. Right, well we know that the volume of a cylinder is always the area of the base, pi r squared, because it's a circle, times the height. Our radius of the cylinder, well, we found it over here, didn't we? It was AE, it's this thing. And so that's our radius, the square root of 64 minus h squared. That's the radius that we're squaring, times h. And, where did the 2 come from? Pi r squared h. Oh, my bad. The h, actually, the height of the cylinder, is not just one of these h's, it's 2 of these h's. And so I've got to actually replace my height here with a 2h, because that's what our height is of the cylinder. So yeah, it's a little confusing that the h becomes a 2h, but look, the h in the formula represents the height of the entire cylinder. And according to the annoying variables given in the question, we've got 2 h's, so I've replaced my height with the 2 h's. The only thing left to do now is to rearrange it slightly to get it into this form, and so I can bring my 2 in front of the pi, and the h after the pi, in order to mimic what we've been given, because we're supposed to show this, right? And so it should be the last line in my derivation. And then I'm left with 64 minus h squared. I can see where that comes from, because the square root being squared, those cancel out, don't they? And I'm left with simply 64 minus h squared. Centimeters cubed, which doesn't quite fit on my screen, but of course I should include those units at the end. Now, part C. Determine, correct to 3 significant figures, the height of the cylinder with the greatest volume that can be produced in this way. So you imagine, this is the volume of the cylinder, this is its function, this is how we can describe the volume of the cylinder. So imagine that if we graphed this, where this is our height, and as the height of the cylinder changes, perhaps the volume changes accordingly. So maybe as the height increases, the volume increases, but there might come a point where when the height increases, the volume starts to decrease, and anyway, we'll see what happens. I'm going to graph this as a function, so I'll change my v to a y, and I've got 2 pi, and I'll change my h to an x on the calculator, and I've got 64 minus x squared. Alright, here we go then. So y equals 2 pi x times 64 minus x squared. And I'm trying to figure out when is this going to be a maximum, so I can have a maximum volume, the greatest volume. So I want to know, where am I at the maximum volume? Where is volume the greatest? So I'm trying to find basically the h value here, which shows what is the value of h when I have a maximum volume. So let's graph it. Now before I graph it, let's set up what is a reasonable window. Looking at what my possible values of the height of the cylinder, which are 2 of these h's, and the h, of course, is my x value. So I've got to make sure that I choose it looks like maybe h could be a little bit less than 8, right? That's like, what, maybe 6 or something? But then I've got to double it, so perhaps the height of the cylinder is maybe as much as 12. So I'm going to make sure that my window at least goes up to 12 or maybe even 13 or 14. So here we go. So my x-min, well, I don't need to look below any of the negatives. How can a height be negative? So let's look at my x-max being, say, I don't know, 14 or something. Now what could be my volume? I can't have a negative volume, so let's go -1 as just so I can see the y-axis. And we need to find out a y-max. What might my volume be? Well, I mean, this is possibly a pretty reasonably big cylinder. So let's start with, say, something like, I don't know, 500 as my maximum possible volume. And when I graph this, you see that your graph immediately rises and then falls, and we can't see what's going on in the middle. So I mean, let's zoom in to these values of x. It looks like something is happening between 0 and around like 8. So let's kind of get a little bit closer on our x window, and our y window, it looks like it's getting much higher. I need to increase my y max. So let's zoom in a little bit to say -1 to 8. And I got to go much bigger here. Let's say something like 1,500 and see if that's good enough. And when we graph it, I can see that my volume increases up until that value and then starts decreasing as the height continues to rise. I'm interested in finding out then, what is this height that produced this maximum value of volume? And so I'll say second calc, and I'll go to option 4, maximum. And so I'll move my cursor to a little bit to the left of the maximum that I'm trying to find, and I'll hit enter. I'll move it a little bit to the right of the maximum that I'm trying to find, and I'll hit enter. And then it wants me to guess, so let's move the cursor very close to the actual maximum point itself, and he'll enter. And it tells us that the maximum occurs when x, right, this is our h value, is equal, to 4.62 if I round to 3 significant figures. So our height is approximately 4.62 centimeters. Now you must be curious, how do you show your work here? We simply copy the sketch from the calculator. So I'm going to create a copy of the sketch in order to get all of my method marks. And so my sketch is going up, a little bit difficult to see right now, isn't it? But it looks like it's going up something like this. And this maximum occurs, so this is my volume and this is my height, and this maximum occurs at 4.62, and then 1,238 would be my volume at that particular value. It says calculate this greatest volume. Well, it's being given to us on the graph as well, doesn't it? 1,238. And that's already more than 3 significant figures. Oh, whoops, it says correct to the nearest centimeter cubed, and that's what I've got right now. So there we go, there's the answer to number 5. Number 6. The area of a circle is equal to 8. So I know that the area of a circle is pi r squared. So basically we're saying that pi r squared is equal to 8. That's kind of what we've been given. Find the radius of the circle. So in order to get the radius alone, we're going to have to divide both sides by pi, and then r is going to be the square root of this amount. Let's see what we get. So the square root of 8 over pi. And we get 1.5957. And of course we could always round that to 3 significant figures, but don't forget units. In this case it's a length because it's a radius, so we're dealing with centimeters, right? The circle is the base of a solid cylinder of height 25. Write down the volume. Alright, we've done one of these already, haven't we? We know that at any cylinder or any prism we can find the area of the cross-section, which in this case is a circle, pi r squared, and then multiply it by the height, h. Now we already know that the area of the circle, as was given at the beginning of the question, was 8. And we've just been told that the height of the cylinder is 25, and so you end up getting 200, and the unit is centimeters cubed because it's a volume. Now we need to write down the total surface area. And so you can look up in the formula booklet that your total surface area of a solid cylinder, meaning that we're using sort of both the top and the bottom of the cylinder, So that means that we've got 2 pi r squared, and then the lateral area, the curved surface around this cylinder, is 2 pi r h. So 2 times pi r squared. Well, remember pi r squared was 8, so there's our 8, and then 2 pi and times r and h. So I think I'm just going to have to substitute on this one. I'm going to put in the more accurate value of r to preserve accuracy, and my height is 25. So let's see what I get. 2 times 8. So there's my 2 circular bases, the top and the bottom. And now the curved surface around the outside is 2 pi times the radius, which is 1.5957 times 25, the height. And we get a total of 266.65, and as you can probably guess, you know that I'm going to round that to 3 significant figures, 267, and because it's a surface area, that's centimeters squared. Last question, number 7. An observatory has got a cylinder with a hemisphere on top. The height of the cylinder is 12, there it is. The radius is 15, there it is. Okay. We need to calculate the volume of the observatory. Well, we can see that the volume is going to be equal to half of a volume of a sphere, whose formula is 4/3 pi r cubed. And it's also going to equal the cylinder, which is pi r squared h. So there's the half of the sphere plus the cylinder. Let's substitute. So our radius is 15. And our height of the cylinder is 12. Let's use the calculator. 1/2 times 4/3 times pi times 15, the radius cubed. And to this we need to add the volume of the cylinder, which is pi times 15 squared times 12. And we get a total volume of 15,550 meters cubed. 15,551, isn't it? If I'm going to go to the nearest meter cubed. Didn't tell us how to round, so as long as I've got more than 3 significant figures, you're okay. If you did want to go to 3 significant figures, I guess you'd be up at 15,600 meters cubed. Just make sure you include the units. Now, the hemispherical roof is to be painted. We need to calculate the area that is to be painted. We know that the area of a full sphere is 4 pi r squared, so the area of half a sphere must be only half of the full sphere's area. So let's substitute. 1/2 4 pi, our radius we know is 15, so we've got 1/2 times pi, times 4, it doesn't matter the order in which I multiply them, does it? Times 15 squared. And we get 1,413.7. That's the area, so that's in meters squared, and of course we can round this to the 3 significant figures, 1410, meters squared. Alright, that concludes the review. Good luck studying.